Hello everyone, myself Dr. Naresh Kumar, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today in this lecture, I am going to discuss some long answer type questions. Some problems are based on long answer type problem. So I want to discuss about some question from the first order and first degree differential equation. So this question bank from module 1, and the name of module 1, first order and first degree differential equation. But today I am taking part B. In part B, there are mentioned long answer type questions. First of all, I want to suggest two reference of textbooks. You can study of the following books. These books are very famous for engineering classes. So, first book, the author names are N.P. Wali and Dr. Manish Goyal. The publications, Lakshmi Publication Private Limited. And second textbook, the name of author is H.K. Das and Rama Verma. Publications are S. Chand and Company Private Limited. So if you have any problem in this subject, then you can study of these books. Now in this lecture, I want to solve some problems from module 1. In the chapter 1 is first order and first degree differential equation. The type of problem is long answer type question. So first problem is problem 1. Problem 1 is 1 minus x square dy over dx, 1 minus x square dy over dx plus xy equal to y cube sin inverse x. This is the problem. 1 minus x square dy dx plus xy equal to y cube sin inverse x. We consider this is equation 1. Now solution. Which question given? I am considering that question as equation 1. And first of all, be dividing function which is given before dy dx to each term. So we are dividing by 1 minus x square on both sides in 1. So here dy dx plus x into y upon 1 minus x square and equal to y cube sin inverse x upon 1 minus x square. Okay, this is equation 2. So which is the type of equation this? First of all, we recall that this equation 2, which is the form. So equation 2 is Bernoulli equation. equation 2 is a Bernoulli equation. Bernoulli equation is dy dx plus py is equal to q by to the power n. This is equation 3. So with the help of Bernoulli equation, we solve this question. When we are discussing about the method of Bernoulli equation, then we have discussed this differential equation in detail, how we can solve this equation. So same procedure you apply in the question. So we apply the same procedure. So this equation 1, 2. Now first of all here, dividing by q. Dividing by yq on both sides. On both sides. Then we get, now 1 upon yq dy over dx and plus x upon 1 minus x square, here y upon yq equal to sine inverse x upon 1 minus x square. This is equation 3. Now 1 upon yq dy dx and plus x upon 1 minus x square 1 upon y square, this equal to sine inverse x upon 1 minus x square. This is equation 4. So now we are converting equation 2 in linear form. So here we are converting equation 2 in linear form. And linear form is dy dx plus py is equal to q. This is the formula of linear. So here there is q, pq are function of x. But in right hand side there should not be function of y. If there is any function of y, then we divide of y. So here is in our question there is yq. So dividing by yq in each term, then we get this equation number 4. So equation number 4 converting in linear form. So here right hand side we get this q. So here 1 upon yq dy dx and plus x upon 1 minus x square n into 1 upon y square equal to sine inverse x upon 1 minus x square. This is equation number 4. Now let 1 upon y square equal to t and differentiating with respect to x. This is considering function. This is equation 5. Differentiating with respect to x, 2, 5. Then we get minus 2 upon y cube and dy dx. This equal to dt over dx. Differentiation of y square. 1 upon y square means minus 2 upon y cube. And differential of y is dy dx equal to dt over dx. So we 1 upon y cube dy dx minus 1 upon 2 dt over dx. So this is equation number 6. This putting in equation 1. Putting from 5 and 6. in 4. So here minus 1 upon 2 dt over dx and plus x upon 1 minus x square into t equal to sine inverse x upon 1 minus x square. Multiply by minus 2 in each term. Then we get dt over dx, here minus, this minus 2x upon 1 minus x square and equal to minus 2 sine inverse x upon 1 minus x square. This is equation number 7. This is linear equation. This is linear differential equation. Linear is dy dx plus py is equal to q. This is general linear equation A. Comparing in 7 and 8. Comparing in 7 and 8. Then we get P. P is minus 2x upon 1 minus x square. And Q. Q is minus 2 sine inverse x upon 1 minus x square. Now finding integrating factor. This is e to the power integral p dx. So in our question, IF is e to the power integral 2x upon 1 minus x square and dx. So this equal to e to the power. This numerator is the differential of denominator. So we can write log 1 minus x square. So log 1 minus x square is 1 minus x square only. This is IF, integrating factor. Now apply solution. Apply solution formula. Solution formula for linear differential equation. Okay, we apply solution formula for linear differential equation. That is y into IF is equal to integration q into IF and dx plus c. This is general formula for linear differential equation. But in our question equation 7, in 7 is dt upon dx. T is dependent variable and x is independent variable. So here is t. So now apply formula here. Y is t and integrating factor is 1 minus x square. And this equal to integration q minus 2 sine inverse x upon 1 minus x square into integrating factor 1 minus x square and this dx and plus c. Okay. Now solving this. So here t into 1 minus x square, this equal to, here this cancel to this. So here minus 2 sine inverse x dx plus c. So next is t into, and here integration minus 2 integration sine inverse x dx plus c. So now integrating this. How we can integrating this? Here I am considering sine inverse x dx plus c. So here considering here function 1. We write here one function and apply here formula uv. Integration by parts. So we write here minus 2 in bracket different integral of integration of 1 1 is x and this is constant sin inverse x minus sin integration 1/2 is x. Differential of this function under root 1 minus x square and whole integration and dx plus c. Here we apply formula. Formula is 1 is first function, sin inverse is x second function. So integration of first function 1, that is x. Second function is constant minus integration of first and differentiation of second. So differential of sin inverse x is 1 upon under root 1 minus x square. This formula is applied. So here integrating this minus 2 x sin inverse x and minus. So here 1 minus x square is t. We integrating this function. 1 minus x square is t. Here considering this 1 minus x square is t minus 2x dx equal to dt. What x dx equal to minus 1 upon 2 dt. So this value putting here, then this result is x dx minus 1 upon 2 dt. Here let theta or u. So here is du upon root u. Here 1 minus x square considering as a u. So this one let 1 minus x square is u minus 2x dx equal to du, x dx equal to minus half du. So minus half du upon root u. Integrating this term. So here minus 2 x sin inverse x and minus plus half. And here u to the power minus half du. So this integration this 1 upon 2 u to the power minus half plus 1 upon minus half plus 1. Okay. And plus c. Here is also plus c and here is plus c. Now minus 2 x sin inverse x and plus c. Plus c. So now next here minus 2 here t into 1 minus x square and equal to minus 2 in bracket x sin inverse x minus plus 1 upon 2 and what happened here u to the power plus half upon half, u to the power plus half upon half. So this 2 cancel and plus c. Now this equal to minus 2 x sin inverse x inverse x. This is minus 1 and 2 cancel plus u to the power half and plus c. Now putting value of u here. So this minus 2 x sin inverse x plus u is root 1 minus x square. This is 1 minus x square and plus c. So this is t into 1 minus x square. This is the answer of equation number 4. This is solution of equation, which equation? Equation 4, 7. This is the solution of equation 7. Putting value of t, this equation 8, t equal to by 1 upon y cube, y square in 8. Then we get 1 upon y square and 1 minus x square equal to here minus 2 x sin inverse x and plus under root 1 minus x square plus c. This is the solution of given problem. This is a complete solution of given problem. Okay. Now I want to solve next problem. This is very easy problem. Problem is 2. Two problem. Similar problem is third. X cube sec square y dy dx. Problem 3. We want to discuss next problem 3. Problem 3 is same as problem 1. So I am giving only hints in this problem. What is this problem? Problem 3 is x cube sec square y dy dx. X cube sec square y dy dx and plus 3x square tan y plus 3x square and tan y equal to cos x. This is equation 1. This is same problem, same Bernoulli equation. This is Bernoulli equation. This is linear differential equation. Linear differential equation. After substituting some value, this question convert in linear. So how we can convert in the linear? Let tan y equal to t. This is equation 2. Differentiating equation 2 with respect to y. With respect to x, d over dx of tan y equal to d over dx of t. So now differential of tan y with respect to x. So here we get differential of tan y is sec square y and differential of y is dy dx. Differential of t is with respect to x dt over dx. So this is 3. This 3 putting in 1. From equation 2 and 3 putting in equation 1. Then we get here x cube. What is putting here? This is sec square y dy dx. This is dt over dx. Plus 3x square t. This equal to cos x. This equation 4. The given question converting in linear after putting some value. Dividing by x cube. Dividing on both sides. So dt over dx 3 upon x cos x upon x cube. This is same as equation dy dx plus py is equal to q. This is general equation A linear. This is linear equation. This is linear equation. Okay. Now compare comparing in 5 and A. Then we get what is P? P is 3 upon x and Q is cos x upon x cube. So finding IF integrating factor e to the power integral p dx. So this equal to e to the power integral p 3 upon x dx. Integration 1 upon x dx. 3 taking common. So here 1 upon x dx. So e to the power 3 log x. So this is log x cube. This is finally, this goes to the power of this. We can discuss here again. IF is equal to 3 log x. We can write e to the power log x cube. This cancel to this. This is x cube. So IF is, we find out x cube integrating factor. This is I. Now solution of linear differential equation. We write here formula. What is formula? Y into IF is equal to integration Q into IF and dx plus C. So in place of y, what is y? We solve question 4. This convert in t. Y is t. So now here is t. IF is x cube. Integration Q. Q is cos x upon x cube. X cube is cancel. Dx plus C. So integration of cos x is sin x. And plus C. Here is t into x cube. Putting value of t. This equation is 6. This is the 6th equation. Putting value of t. T is sec y. 10y. 10y into x cube equal to sin x and plus c. So this is complete solution of problem 3. First of all, basically the problem 3 is a linear differential equation. But after substituting some value, that convert in direct linear. So I am considering 10y equal to t. In this question, considering 10y equal to t. This 10y. This is disturbing the question. And here is sec square y dy dx. So after considering 10y as a t, then this question convert into full form of linear. So this is linear differential equation after considering this. So 10y is t, this equation 2, differentiation equation 2 with respect to x, then we find d over dx of 10y, d over dx of t. So differential of 10y is sec square y. Again differential of y is dy dx equal to dt by dx. Now putting from 2 and 3 in equation 1. Putting values from 2 and 3 in equation 1. Okay. So now after putting this value, x cube dt over dx plus 3x square t equal to cos x. This is equation 4. Dividing by x cube on both sides. And dt over dx plus 3 upon x t equal to cos x upon x cube. This is equation 5. This is completely linear differential equation. The type of equation 5 is this one. This is general form of linear. So this is linear equation. After comparison of equation 5 with A, then we find value of P. P is 3 upon x and Q is cos x upon x cube. So now first we find integrating factor IF. IF formula is e to the power integral P dx. We have discussed all formulae in last video when we define the linear differential equation. So e to the power pt 3 upon x dx. E to the power 3 is out and integration 1 upon x dx. So e to the power 3 log x. This 3 goes to power of x. Then we write here if equal to 3 log x. 3 goes to power of x log x cube. Log cancel by e. So here we find out the value of if is x cube. Solution of linear differential equation, we write formula. We write here formula. Formula is this: y into if. This is general formula. Y into integrating factor equal to integration q into integrating factor dx plus c. So y is t in equation 5. Y is t. If is x cube equal to cos x upon x cube into x cube dx plus c. X cube is cancelled. So t into x cube equal to integration of cos x. Integration of cos x is sin x plus c. This is equation 6. Now in 6, putting value of t, then we get the solution of 1. This is the solution of equation number 5. But we want solution of equation 1. After putting value of t here, then we get solution of 1. So we are putting t equal to 10 by. So t equal to 10 by means x cube 10 by equal to sin x plus c. Next problem, solve 7. E to the power x dy dx problem 7. E to the power x dy dx equal to 2y square equal to 2y square plus y e की power x plus y e to the power x. This is equation 1 which is given in our question paper. So how we can solve this question? This is very easy question. E to the power x dy dx, this term writing to left side. This is equation 2. Dividing by e to the power x on both sides. Dividing by e to the power x on both sides into dy over dx. Here is only by 1 upon e to the power x into 2y square. dy over dx minus y, this term taking in numerator e to the power minus x and into 2y square. This is equation 3. Now this is Bernoulli equation. Equation 3. Equation 3 is a Bernoulli differential equation. So now Bernoulli differential equation, now Bernoulli differential equation convert in linear form. So how we can change in linear form? Here given dy dx minus y equal to 2y e to the power minus x. So dividing by y square, this y square eliminate, y square eliminate from right hand side. So dividing by y square to 3, we get here 1 upon y square dy over dx and minus y upon y square equal to 2 e to the power minus x. So 1 upon y square dy over dx minus 1 by e. This is equation 4. Here considering this result, coefficient of p considering as a t. Now 1 upon y square dy over dx minus 1 upon y equal to 2 e to the power minus x. This is equation 4. This is 4 equation. Now here let coefficient of p is equal to t. Coefficient of p is 1 upon y. This is equation 5. Differentiating with respect to x. So here minus 1 upon y square, differential of y. Differential of d over dx of equal to d over dx of t. So this differential is minus 1 upon y square. Differential y is dy dx equal to dt over dx. So this is the differential of, this is considering function. This is given question. Okay, from 5, this is 6. From 5 and 6 putting in 4. Then 4 convert in linear. So we write here this minus sign taking this side. So here minus dt over dx and here minus, here is t and equal to 2 e to the power minus x. Minus x. Multiply minus sign. So dt over dx and plus t equal to minus 2 e to the power minus x. This is equation 7. This is 100% linear. So comparing this linear, dy dx plus py is equal to q. Now p, where p is 1 and q is minus 2 e to the power minus x. Comparing this equation A. Compare in 7 and A. 7 and A, then we get P. Now IF, integrating factor, IF, e to the power integral factor. What is P? P is 1 here. So this is the e to the power x. This is IF. Now formula. Formula for linear differential equation. This is y into IF is equal to integration k into IF dx plus c. This is 8 formula, putting value of y and integrating factor. So y is t here and integrating factor is e to the power x. This is equal to integration q minus 2 e to the power minus x dx plus c. This cancel to this, minus 2 is common, dx plus c minus 2x plus c. Putting t, value of t, This is same as t to the power x. This is 9. Now putting value of t, we get complete solution of equation 1. Now putting value of t in 9. So we get here t is 1 upon, what is t is? Value of t is 1 upon y. So here 1 upon y and e to the power x equal to minus 2x and plus c. This is complete solution of problem given. At last, I want to solve next problem, problem 4. So what is problem 4? That is very most important problem. Problem 8. I want to solve problem 8. So here is some mistake. Here is y by this. So here I want to solve problem number 8. What is question 8? 2 dy dx minus y sec x equal to y cube. This is problem is wrong. This is 2 dy dx minus y sec x equal to y cube into 10x. This is the correct question. 2 dy dx minus y sec x, problem 8. 2 dy dx minus y sec x equal to y cube 10x. So this is equation 1. This is also Bernoulli equation. This is Bernoulli equation. Okay. Now change equation 1 in linear form. So dividing by q on both sides in 1. Dividing by, now change equation 1 in linear form. Dividing by y cube on both sides in 1. So we write here 2 upon y cube dy dx minus y upon y cube and sec x equal to only 10x. So now 2 upon y cube dy dx minus sec x into 1 upon y square equal to 10x. This is equation 2. This is 2 equation. Okay. This is question. This is question. After dividing by cube, we get equation 2. We are changing in linear form. So linear form, in right hand side, there should be only function of x, that is q. So here, and there is not any function of y. If any function of y, then you divide y on both sides. So here is only 10x. We divide by this y cube on both sides. So now 2 upon y cube dy dx minus sec x into 1 upon y square equal to 10x. This is equation 2. Now let here coefficient of p. Coefficient of p is equal to t. Coefficient of p is 1 upon y square. So 1 upon y square is t. This equation 3. Differentiating with respect to x, 2, 3. Then we get here d over dx of 1 upon y square equal to d over dx of t. So differential of this minus 2 upon y cube, and differential of y is dy dx equal to dt over dx. So minus sign taking this side, 2 upon y cube dy dx is equal to minus dt over dx. Okay. So this is equation number 4. From 2, 3 and 4 putting in 2. From equation 3 and 4 putting in 1. Then we get here. So here this is 2y cube dy dx. This function, this equal to here minus dt over dx. So here I am writing and minus sec x into t equal to 10x. Multiply by minus sign dt over dx and plus sec x into t equal to minus 10x. This is equation 5. Equation 5 is linear differential equation. Okay. So this is general equation is dy dx plus py is equal to q. This is general equation A. This is general linear equation. This is given question. Now comparing in 5 and A. Comparing in 5 and A. Then we get here. So what is P here? P is sec x. What is Q here? Minus 10x. Okay. Now finding IF. IF is integrating factor. That is e की power integral p dx. So IF is e की power integral p is sec x dx. So integration of sec x is e to the power log sec x plus 10x. This is integration of sec x dx. This is log sec x plus 10x. This is formula of integration. So we apply here. So this equal to log cancel by e. This is IF. This is equation 6. Now apply formula for linear differential equation. Solution formula linear differential equation. That is y into IF equal to integration q into IF dx plus c. This is 7. Now putting value. What is y? Y is t. What is IF? IF is sec x plus 10x equal to Q. Q is minus 10x. And what is IF? Sec x plus 10x and dx plus C. So this T into sec x plus 10x and equal to minus common multiply 10x. So multiply 10x, this equal to minus common and multiply by 10x. So sec x 10x dx and plus 10 square x. Plus C. Here multiply by this 10x to this function sec x 10x. Multiply this 10x to 10x 10 square x. So now T into sec x plus 10x and this equal to minus, here integration sec x into 10x dx and plus integration, here is 10 square x. So I am writing sec square x minus 1 dx and plus C. Here formula tan square x equal to sec square x minus 1. We apply this formula. So here T into sec x plus 10x equal to minus integration of sec x 10x is sec x. Sec x 10x integration is sec x because the differentiation of sec x is sec x 10x and plus integration sec square x dx and integration 1 dx plus C. So this equal to minus here sec x and plus integration of sec square x sec square x dx, that is 10x and minus x plus C. This equal T into sec x plus 10x dividing by this function. So here T equal to minus sign, this is sec x plus 10x. So dividing by this, (10x). So dividing by this sec x plus 10x and upon sec x plus 10x. And here is minus x upon sec x plus 10x and plus C. So next is T equal to minus, here is 1, this term cancel to this, and here is minus x and here sec x now next minus 1 plus x sec x plus 10x multiply conjugate bracket sec x here multiply conjugate bracket of this sec x minus 10x multiply in numerator and denominator. So here we get T, this equal to minus 1 plus x sec x minus 10x, and but in denominator this is formula sec x plus 10x and sec x minus 10x. So that is sec square x minus 10 square x Okay, this is 1. This formula is sec square x minus tan square x. This is 1. So finally answer is t equal to minus 1 plus x sec x minus tan x upon 1 plus c. So t equal to x into sec x minus tan x and minus 1 plus c. So this is total constant. Minus 1 plus c is constant, and putting value of t. What is t here? T is 1 upon y square. T is 1 upon y square. So 1 upon y square equal to minus x sec x plus tan x and plus c1. This is the complete solution, where c1 is minus 1 plus c. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.